Hi guys, this is for worksheet number 2, graphing quadratics 8.1, 8.2, and 8.3. So bring this on down. Let's take a look at what we have here. Okay, so we want to answer the question about the domain, the range, any roots, anything further. We'll fill that in as we go down, okay? All right, as far as parabolas opening up and down, right now our domain will be negative to positive infinity. So we'll go ahead and do problem number 1 and problem 3. So it goes forever left and forever right. So our domain on both of these is negative to positive infinity. Our range, that's our y component. So it looks like on this graph, I have a vertex here of -2, and it goes down to -5. So my range goes all the way down, and it's going to be a square bracket because it's included as a point, from -2 to infinity. It's opening up. And then we'll find on this one, it looks like my vertex appears to be 1, 0. So my lowest y value is going to be 0. So it's a square bracket because it's still a point. And that goes to infinity because it opens up. If it opens down, remember, it'll go to negative infinity. Minimum or maximum value of a function of x. So function of x means the same thing as our y component. And with parabolas, it is the vertex, the y component of our vertex. So we have a minimum value on this one because it opens up. My minimum value is -5. If we go to number 3, my minimum value, the lowest it goes in the y direction, is 0. So we also have a minimum, and our minimum on this one is 0. Do we have any roots? It does appear that it crosses the x-axis at those 2 places. So we do have roots. We have 2 of them. We can't see exactly where it crosses. It's not like a nice whole number. So these are actually called irrational roots. Okay, an irrational root. And then on this one, does it cross or touch the x-axis? It does indeed touch the x-axis. So yes, we have roots. We have one root because it touches once. Remember we said that was a bounce. And then that's going to be, my root is going to be at 1, 0, which happens to be the vertex in this case. So remember, irrational, it won't cross. It crosses the x-axis, but you can't tell exactly where because it didn't cross a nice whole number. Remember the difference between rational and irrational numbers. A rational number is any number that can be written as a fraction. An irrational number is a decimal that goes on forever, and you can't find the fraction that goes with it. We want the vertex as an ordered pair. Okay, so we have our vertex was -2, 5 on number 1. On number 3, our vertex was 1, 0. Our axis of symmetry, remember that's going to be a vertical line, so it's x equals, so that tells you it's vertical, and so is the x component of the vertex. And again, same thing on this one, the x component of our vertex. And where is the graph increasing? Okay, so where is it increasing? So we're going to go back and take a look at the graph. Increasing means it's turning upward. So if I were to pick any 2 points from here all the way over this way, it's increasing. So it's increasing from -2 and going forever to infinity. On this one, it's increasing from 1 and going to infinity as well. These are all increasing, and increasing means that if I were to find the slope between any 2 of those little tiny points that we just put on the right side, that would mean we would have a positive slope, okay? So it's increasing on number 1 from -2 to infinity, because it'll continue to grow. And on number 3, it's increasing from 1 all the way to infinity. And the interval where it's positive, that means, where's it positive? It means it's above the x-axis. So we have to go back and take a look at our graph. Where is our graph above the x-axis? Well, it's above the x-axis here. So we're going to have to estimate that. So we're going to have to maybe estimate that as like -4.1, 0. We could say that's about where its root is. So it's positive there. So from negative infinity to -4.1, it's above the x-axis, but it's also above the x-axis here. So that looks like it's about, I don't know, maybe 0.1, excuse me. And it's all positive here, so that goes to infinity. So again, positive is above the x-axis. This entire graph is above the x-axis except for right at the vertex. So this is positive here, coming all the way down until it gets to the vertex, and then it's positive here. So it's positive from negative infinity to 1, and then it goes from 1 to infinity. So we don't include the 1 being that it is positive. It's actually a 0 right there, okay? Let's head down the graph, see what else we have on problems. Okay, so problem number 5, it's this one. So let's look at our vertex. Our vertex appears to be 0, comma 1, 2, 3. We can ask a lot of questions on this one. So our domain, remember, it's negative to positive infinity for our parabolas. Our range, look at our y value. So it's going to go from 3, square bracket, because it's a point, all the way to infinity. That's where our range is going. Do we have a max or a min? Well, the lowest point is the vertex. So this is a minimum because it opens up. It'll be a maximum if it opened down. And our minimum value is 3. Use the y component on that one. Do we have any roots? When we looked at the picture, it does not cross the x-axis. So our roots are actually called complex roots. And we will explain more of that later because it does not cross the x-axis. Okay? Won't cross the x-axis. The vertex has an ordered pair. I forget what the vertex was. Oh, it was 0, 3 was our vertex because 0, 3 was the lowest point, so that's a turning point. Axis of symmetry, remember that is the x equals, it's vertical, it's the x component of the vertex, so x equals 0. The interval where it's increasing, so it's going to be increasing. Remember, that's where it starts going up. So if we go back up to our picture, it's increasing from here all the way over. So this whole side's increasing. So it's going from 0, increasing from 0 all the way to infinity. So that's where it's going to increase. And see if we have any more problems on this page. I think we took care of all of the odds on this unit. Oh, and let's see. Number 7 talks about, we're applying a problem. It says, a rancher is building a rectangular corral for her horses. She can afford 300 feet of fence. So if I were to go this, and it's all the fencing, it would be only 300 feet in length. Wants to build the area of the corral as large as possible. So the graph below describes the corral as far as width. So notice this has a vertex at 75, 5,625. So let's answer those questions below. What is the vertex of the function? Well, we just said the vertex was 75, 56, 25. 56, 25. Okay, so that's our vertex. What does it mean in the context of this problem? It means I can have a width of 75 feet, okay? And I can have a max area of my corral of 5,625 square feet. What is the point? What does the point 30, 65 mean in the context of this problem? It means that if I had a width of 30 feet for my fence, then my area would be 3,600 square feet. And that appears to be all for this page.